Sensors of all types long have been a vital, well-understood feedback component for discrete control and operational monitoring. More recently, advances in performance and system simplification have helped close the loop to make machine vision sensor feedback for real-time control more possible and practical. From encoders and resolvers to vibration and proximity sensors, the applications are as diverse as the markets they serve. But machine vision has developed into a sensing technology all its own. Inspection, real-time control, feedback, colorimetry, and collision detection all are possible under the machine vision umbrella. We recently surveyed the audience of control design to get a snapshot of the types of sensing being used on their machines, including for machine vision. We also asked what they're using it for, where the data travels, and just how satisfied they are with their vision system configuration software. We've also asked Ned Leckie, founder of Leckie Integrations in Little Falls, New York, to join us to interpret those answers from a system integrator's perspective. Ned is an ME and EE with 25 years of experience in control system and machine vision and consults with OEMs, system integrators, and machine vision providers and users. Ned, thanks for joining us today.
Hi, Jim. Great to be here. Thanks for having me.
Let's get started with sensors and their connections to the I/O. Inductive proximity and photoelectric sensors are being used by more than 70% of respondents. About 2/3 use process variable sensors for measurements of temperature, pressure, and the like, and rotary encoders or resolvers. And about half say they use linear position sensors as well as capacitive and ultrasonic proximity sensors and vision sensors. Hardwiring is still the connection of choice at more than 65%. Device-level digital networks and serial 232, 422, 485 communications were the only others used by more than 10% of respondents. Regarding machine vision, of the 50% that say they use machine vision, and most of them are applying it for inspection, but close to a quarter are generating feedback for real-time machine control. As an integrator, Ned, which types of inspection applications are best suited to machine vision these days?
Well, certainly the big ones are still robot guidance, multi-point inspection and metrology, and of course character reading and verification. You will see machine vision used in simpler applications sometimes, simpler point-to-point kind of measurements or assembly verification. But in a lot of these applications these days, it's just not cost-effective. There are other good solutions that can be used to solve these kinds of problems.
Now, with machine vision being indicated by a quarter of the respondents for use in a real-time machine control application, do you think that's a respectable percentage these days, or can it be higher, considering the available technology?
Well, I actually think that is a healthy percentage. 25% does seem to be about right. There's so many real-time control applications that can be solved with rotary or linear encoders. And for applications where a more traditional sensing technology works, that's going to be a lot easier than getting involved in machine vision. There's a bit of a slippery slope. Once you choose a vision-based solution, you're committed to not just camera, but also optics, a lighting solution, and trying to solve the problem of extraneous illumination, uniformity of appearance of the parts to the camera, things like that. So I'm not surprised that percentage is right around where it is.
Okay, let's talk cameras and communications. Almost 40% of survey respondents are using all-in-one integrated smart cameras. Almost a third are using vendor-built vision with camera, frame grabber, and processor, while 17% are building it themselves. Only 10% say they rely on an integrator to build them a system. So, Ned, what are the big advantages of using all-in-one integrated smart cameras? And are you surprised by the small percentage reporting the use of an integrator for this?
Well, wasn't that the whole idea, to eliminate the need for a system integrator in a lot of simpler kinds of applications? That was really what drove the market in the direction of smart cameras to begin with, and I think it has really succeeded beyond anyone's wildest imagination. There are many applications, for example, simple presence-absence, some character recognition and verification kinds of applications, even some sort of pattern matching kinds of applications that can be handled by smart cameras very admirably. The nice thing about a smart camera is that you've got the software platform and the hardware platform and the optics and often even the illumination package all integrated into one piece. And a manufacturing engineer who's got some experience integrating sensors of different kinds can often take on something like this and pull it off without the need for an outside integrator.
In addition, more than half report that they find their machine vision software to have good functionality and that it is easy to use. In that vein, Ned, it wasn't that long ago that the vision companies had to provide free training for the software because it wasn't easy to use. So what has changed?
Yeah, well, it's kind of a self-fulfilling prophecy. You simplify the application space. You say, hey, I'm going to provide this smart camera product that only does a certain number of things, but it does them very well and in a relatively straightforward way. And all of a sudden, you can develop new software applications that are much easier to understand. They don't have thousands of bells and whistles on them that allow you to get involved in all of the fine, nuanced aspects of machine vision that some of us have come to know and love and occasionally hate. So that really is the beauty of the smart camera. Now, of course, at the same time, if you have a potential machine vision application that doesn't fall into one of those categories, that doesn't fit one of the application models that the vendors have put together, then all of a sudden using machine vision looks much more difficult because now the smart camera is not a viable alternative for you. It's not an option that's going to work. And you're pushed back into a world of needing a fully custom machine vision system in an era where there are fewer integrators because we eliminated the need for them.
Our study also revealed that Ethernet and hardwired each are the vision system's communications link preferences of 25% of the respondents, with camera link at 12% and then proprietary serial USB and fiber optic named by 5 to 10% of participants. We also found that fewer than a quarter of respondents are using wireless connectivity for their sensors. Those who do so only because it's difficult to run wires or supply power at these places. So, will wireless eventually play a bigger role in machine vision, Ned?
Well, I think the move to wireless is inevitable. I mean, we're seeing it in so many other technology segments. It just has to happen. I'm seeing it in a lot of the work that I'm doing right now. Certainly, I'm doing a lot of systems with 802.15.4, the so-called Zigbee set of standards where there are a very large number of vendors now that have low cost and high reliability product offerings that can interconnect sensors. Now, of course, vision has the problem of needing much higher bandwidth than most sensors, but what we've seen, certainly looking at things like Ethernet and the way that's evolved over the past 10 or 20 years, all of these technologies just get faster and faster and faster, and the wireless interconnect will get faster and faster too. And one of the things that drives integrators and machine builders in a wireless direction certainly is just the cost of interconnect. Cable is expensive, connectors are expensive, and the labor that's required to route and run all of that stuff is very, very expensive. So there's something that's very attractive about being able to put a sensor on one end of a machine and only have to get power to it and then be done.
Is there anything else that you think is important to consider when deciding on sensor and vision system design?
Well, I guess one of the big things for me is that everything always really needs to be approached as a system design problem, not an individual sensor, an individual actuator, an individual software algorithm. Where my clients frequently get in trouble, or let's just say they'll wind up in places where they would rather not be, it's often because of having focused on one aspect of the problem or 4 aspects of the problem while forgetting about the other 1, 2, or 10. And this is really where you live and die in any kind of engineering design problem, in my view. You need to look at the complete system problem, think about computing, think about sensing, think about actuation, think about control methodologies, and really take a little bit of time, which can be hard sometimes, especially with tight deadlines and small budgets. But when we don't think about this stuff up front because we don't have the time or we don't have the money, and then we have to fix it later on, every single time we find out that it winds up taking more time and more money than it would have if we had just looked at the system and designed it from scratch properly in the first place. It's a hard lesson to learn. I've learned it many, many times, so I know it well. It's easy to say and hard to do in practice, but with machine vision in particular, this is a complicated sensing technology. There are a number of different vendors that make great products. There are a lot of different software architectures. There are a lot of different interconnect methodologies, lighting, optics. And certainly if you're going to be building very complicated and sophisticated sensing systems into a much bigger system, you want to make sure that everything is going to fit together and operate properly before you really commit.
Ned, thanks for some insightful explanations of the decisions that go into the design and installation of vision systems.
Well, thank you, Jim. It was certainly my pleasure, and I hope it was helpful.
We really appreciate your sharing your analysis with other controls engineers on this Market Intelligence Report.